Welcome back, everybody. Moving on in Chapter 12, our chapter on circles. Okay, we're skipping around a little bit, only doing the important stuff. In 12.3, we're talking about something called inscribed angles. Okay, objective, define the measure of an inscribed angle and intercepted arc. We'll tell you what the heck that means right now. Alright, so with this section, here's kind of the setup we're dealing with. Kind of informally, when I say inscribed angles, we're just talking about an angle that's inside of a circle. Okay, let's do the formal definition part. First off, we need to talk about something called a chord. I'm going to say a chord is a segment whose endpoints are on a circle. So an example of a chord here would be UT, okay, because U is on the side of the circle, T is on the side of the circle, so that's a chord. Okay, a diameter would be a chord as well. Okay, then an inscribed angle, I'm going to say it is an angle whose vertex is on the circle and whose sides are chords of the circle. So angle T in this case would be an inscribed angle because its vertex is on the circle and its sides are chords. Okay, so in other words, it fits inside of the circle. That's the inscribed idea. And then the last part of this, we have the intercepted arc. I'm going to say it's an arc with its endpoints on the sides of an inscribed angle. So in other words, an example of an intercepted arc would be this arc UV, okay, basically because it's formed by an inscribed angle. We could say that inscribed angle T intercepts arc UV. And then so the one theorem we're going to give you about inscribed angles, interceptor arc, is this. I'm going to say the measure of an inscribed angle is half the measure of its intercepted arc. Okay, so in other words, if I have inscribed angle B, its chords intercept arc AC, we're going to say that angle B is half the measure of AC. Okay, inscribed angle is half the measure of the intercepted arc. Alright, so let's show you how that theorem works by doing some problems. Okay, problem 1, part A says, what are the values of A and B? Okay, notice it looks like A is an arc and B is a inscribed angle. So we're going to look at finding both arcs and angles. Let's start off with part A. Well, what is A? A is the arc that is intercepted by, if I trace the endpoints of A back to point Q here, we have this angle PQT, so we could say that angle PQT intercepts arc A. Now the theorem we gave is we said that the angle is equal to half the arc. So filling what we know, the angle is 60 equals 1/2 times the arc, which we don't know is A. What I have then is a simple equation I can solve for A if I multiply both sides of this equation by 2 to get rid of my fraction. That leaves me with just A is equal to 120 degrees. Okay, so that's how we can use an angle to figure out an arc. We can also go the other direction. We can use an arc to figure out an angle. Now I also want to know angle B. Now if I trace angle B out to the sides of the circle, what I see is that B intercepts this arc from P all the way around to S. And what is that made up of? That's made up of the A, the 120 we just found, plus the 30. So in other words, that's going to be an arc of 150 degrees from P to S. So same formula then, angle equals half the arc. In this case, my angle's B equals half of the arc, which is 150. Okay, half of 150 is just 75, so in this case, B is 75 degrees. Okay, so that's how you can use that theorem we just gave you, angle equals half the arc, to solve for both arc measures and angles. Okay, part B is the same idea. I want you to pause the video, give that a shot, and then hit play to check your answer. Alright, part B, same idea. We want to find both x and y. Looks like x is an angle, y is an arc measure. Okay, so for x, again, I'm going to use angle equals half the arc. Let's see here, x is the angle. and that's going to be equal to half the arc it intercepts. If I trace x out to the edge of the circle, I see that it intercepts an arc measure of 44. Okay, so x is just half of 44, in other words, 22 degrees. All right, we'll do the same thing for part y. Again, we have angle equals half the arc. In this case, y is an arc. So y times 1/2 is equal to its angle that intercepts it. Okay, well, if I take the arc y and I trace it back to the circle, we end up coming back to this angle of 54 degrees. Okay, so 54 equals 1/2 times y. If I multiply both sides of that equation by 2, that's going to give me that y is equal to 108 degrees. Okay, now what we showed in the last two problems is really it for this section. Okay, you could probably go on and do the homework and just do fine with it. What I want to talk about first is a few shortcuts that are going to make life easier. Okay, a few corollaries to that theorem we just gave you. Okay, these aren't things you have to memorize, but like we said, they're going to make life easier. Okay, we'll read through these and talk about them. Corollary 1, two inscribed angles that intercept the same arc are congruent. Okay, so here I know that angles A and B are congruent to each other because they both intercept the same arc. And the reason that is true is they both be half of that arc. So if they're both half of the same arc, they have to be equal to the same measure. All right, corollary 2 says an angle inscribed in a semicircle is a right angle. Remember, semicircle is half a circle. So if we ever have an angle that inscribes half the circle, I know that half the circle is just 180. And half of that is 90. Okay, angle equals half the arc. When I divide 180 by 2, I get the 90. Okay, corollary 3, this one is maybe the tricky one to explain, but we'll talk about it. So it says opposite angles of a quadrilateral inscribed in a semicircle are supplementary. Okay, so in other words, opposite angles like A and C or B and D will be supplementary. They'll add to 180. Okay, why is that? Well, let's explain that for you here quick. Let's say I look at A and C. Let's take a look at angle A, the inscribed angle. It intercepts this arc from D to B. Okay, inscribed angle C, then the opposite angle intercepts the arc from D to B the other direction. Okay, so basically between these two intercepted arcs, we have the entire circle, 360 degrees. So if I take that 360 divided by 2, I get 180, meaning that these two angles here have to add up to 180 because they're intercepted arcs. Doubling them has to make the whole circle. All right, let's apply these corollaries now. I've got parts A, B, C, and D. Tell you what, why don't you take a few minutes, pause the video, see what you can work through on these problems. They're pretty quick to utilize those shortcuts. And then hit play if you get stuck, or hit play to check your answer if you get them all. All right, otherwise, let's go through these here. Okay, problem 1, pretty simple. Okay, since this diameter here is going through the center of the circle, I know that above it is going to be a semicircle, half the circle. Okay, so since angle 1 intercepts half the circle, I know that right off the bat, angle 1 is just equal to 90 degrees. Okay, so no calculations necessary. Since that's a semicircle, it's 180. If I divide by 2, I get the 90 right here. Okay, B uses our first corollary. Okay, angle 2 I know is just going to be 38 by looking at this. Why is that? Well, this angle of 38 intercepts this arc right here, which will be double the angle. Okay, 38 times 2 is going to give me a 76 degrees. And since angle 2 intercepts that same arc, I know it's just 76 divided by 2, which will be the same thing as the 38. Okay, so here again we have two angles intercepting the same arc, therefore they have to be congruent to each other. All right, part C is going to utilize our third corollary, the quadrilateral inscribed in a circle corollary. Okay, we've got angles 1, angle 2, angle 3, and angle 4 we want to find for this one. Okay, now 1 right off the bat, since it inscribes it intercepts a semicircle, I know it's just 90. Okay, because this line going through the center shows me half the circle's below. Same thing with angle 3. We get a 90 right off the bat. Now for angle 4, what I have is just basically back to the first question we looked at. Angle 4 intercepts the arc made up of the 80 and the 60. Okay, 80 plus 60, in other words, is 140. And we know that the angle is half the arc, therefore angle 4 is just half of that, 70 degrees. Okay, here's where our corollary comes into play. Since angle 4 and angle 2 are opposite angles in a quadrilateral inscribed in a circle, I know they'll be supplementary, so angle 2 will just be 180 minus angle 4, which is 70. In other words, 110 degrees. Okay, now I suppose I don't need that corollary. It's nice to know. What I could do instead is if I could take 360 minus the 140, which would give me a 220 degrees. And then I can know that angle 2 intercepts that arc, so if I divide it in half, I'd get the 110 as well that way. Okay, but that corollary just makes life a little bit easier. Okay, part D, we want to know angle 1 and angle 2. This one has a little bit of problem solving as well. Well, 2 right off the bat I know is 90 because it inscribes a semicircle. Okay, then there's a couple of ways I could go about figuring out angle 1. What I could do is I could take this 60 and divide it in half to get this inscribed angle, which would be 30 degrees. And then I have a triangle. I could go 180 minus 90 minus 30 to get 60 for angle 1. Okay, or I could take 180 for this semicircle on the bottom, subtract 60 from that, and get 120. And then since 120 is intercepted by angle 1, if I divide that in half, I get the 60 there as well. Okay, so one great thing about these problems is there's different ways to do them. Okay, there's different ways to approach them. Okay, so there's some good problem solving happening as you go through these. Okay, last thing we're going to talk about here is another theorem that basically just gives us the same result. Here's what I mean. It says the measure of an angle formed by a tangent and a chord is half the measure of the intercepted arc. Okay, so if I have a chord in a circle and a line that's tangent to that circle, and that makes an angle, okay, it's not technically an inscribed angle because it's not all the way in the circle, but it's still on the side. My formula is still angle equals half the arc. Okay, so different situation we're talking about here, but same result, angle equals half the arc. Let's apply that to a question here. Problem A says in the diagram SR is tangent to circle Q. Okay, if the measure of arc PMQ is equal to 212, what is the measure of angle PRQ? Okay, so we're given PMQ. Let's find that. So P through M up to Q is 212 degrees. And I want to know what is angle PQR. PQR is right here, so in other words, that's this angle. Okay, there's a couple ways I could figure this out. The first thing I could do is I could figure out what arc PQ measures. And that's going to be equal to 360 for the entire circle, minus this 212. There we go. So we get a 148 degrees. And then like we said, angle equals half the arc. If I take that arc and just divide it in half, I end up with 74 degrees for my angle. Okay? Another approach I could take is right off the bat, I could divide this 212 by 2. That would give me this angle here, which would be 106 degrees. And then since I have a linear pair, I know that these two angles will be supplementary. If I go 106 or 180 minus 106, that would give me 74 as well. Okay, so a couple different ways to think about that, a couple ways to approach it. Problem B is the exact same idea. Okay, you're going to have to find a few more angles though. Why don't you take a minute, pause the video, work through B, and then hit play to check your answers out. Alright, let's go through this one. And notice there's going to be different orders we can solve this one in. I'm going to find X first because that's kind of the one we can do directly. X is the angle that intercepts this arc of 150. So X is just 150 divided by 2 because the angles equal half the arc. In other words, 75 degrees. Okay, for Y, notice Y is the part of the circle that makes up everything but this 150. So to solve for Y, what I could do is I go whole circle, 360, minus 150, which would give us a 210 degrees. For W then, there's a few ways I could approach it. Since I know that X and W are supplementary, if I take 180 minus X, that'll give me W. Okay, or since W, this angle, intercepts the arc of Y, which is 210, I can just divide 210 in half to get the W as well. Either way I go, whether I go 180 minus a 75 or 210 divided by 2, that's going to give me a 105 degrees. All right, there you go. There's section 12-3. Okay, pretty simple formula you're working with. Angle equals half the arc, but there's a lot of different ways we can set these circles up. There is problem solving involved with this. Okay, so put your thinking caps on, give the homework a try, let us know if you need help, and we'll see you folks later.